We're surrounded by polymers so much that we often take them for granted. So sometimes incorporating them into a little magical effect can increase the curiosity. Here I have 3 cups and some ordinary water. I'm not in the lab for this video, so I can at least prove to you that it's drinkable if nothing else. Tastes okay. And then spread out my other cups. Here's the trick. I've got my water and I'm going to pour it into the middle cup. In it goes. Now your job is to keep an eye on the cup with the water in it. Are you ready? Watch closely. Do you think you got the cup with the water in it? Yeah, I probably made that a little bit easy. One more time, okay? Keep watching. So, which cup has the water in it now? Oh, you think it's still in the middle? Well, not too obvious? Okay, let's find out. Perhaps not. Okay, well, it can be tricky to keep an eye on them. Maybe it's in this one? Still not there. So I guess it definitely has to be in this one, right? Maybe to be sure I should tap it over my head. Nope, absolutely nothing in this one either. So the water seems to have disappeared. Now, maybe if we add a little magic powder, it might come back. And by magic powder, I actually mean a bit of ordinary table salt. So I'm just going to stir in about a teaspoon into each of our cups. And give that a stir. Teaspoon. Give that a stir. Teaspoon. Give that a stir, and we've got 3 cups on the go. Now let's leave them for a second while we get another look at the trick. As you might have guessed, all of this has something to do with polymers. Here are another 3 cups which are transparent, and you can see that in the middle cup of the 3 I've placed a small amount of powder. Now this is sodium polyacrylate. You can get the details over on the EIC website, as always, for how to do this yourself. This polymer has a backbone a lot like polyethylene, but with a negatively charged group of atoms called a carboxylate, coming off of every second carbon. If that was all that we had, then the polymer chains would repel apart, and so we need something there to balance out that charge, and in sodium polyacrylate, positively charged sodium ions will do the job. With the sodium ions around, which I'll model with these green molymods, the chains can all tangle up together, like this, and there you can minimize the strain that they're under by balancing out the forces between the chains and also the forces along the chains, a little bit like a rubber band. Now, when we introduce some water, the water is able to penetrate into the polymer chains because it can form hydrogen bonds to the carboxylate groups. While the forces between a negative ion and a positive ion like sodium are stronger than anything that the neutral water molecules can come up with, there is now a massive excess of water molecules outside the polymer. So they're going to diffuse into where the concentration is lower. Meanwhile, sodium ions will diffuse out to where their concentration is lower. Where water displaces sodium, the chains will be forced apart because, unlike the sodium ions, the water molecule has to line up in just the right way in order to form hydrogen bonds. This causes the once small material to swell up until we form a gel. Similarly, sodium ions will diffuse out until everything comes to a balance between the strength of the bonds, strain of the polymer chains, and the concentration of the sodium inside and outside of the gel. And that's where our salt comes in. If we add some extra sodium ions outside the gel, then they are going to begin to diffuse in, and again some of that water will diffuse back out again in order to maintain a new balance. If that happens and you leave it long enough in time, then you'll find that you might start to form a bit of a slush that's coming out in this case. Since these materials were invented in the 1960s, originally to solve problems with keeping crops irrigated, they've probably played a role in most of our lives when we've needed a little bit of extra help to keep dry. And now you understand how they work. There are so many ways to play with this trick. Share some of your best ideas with us via the EIC website, and then I'll see you in a couple of months.